igcse physics paper 2 radioactivity part 2. Alpha and beta particles may be emitted by unstable nuclei. When an unstable nucleus emits an alpha particle, its atomic proton number increases by 1, stays the same, decreases by 2, decreases by 4. So an alpha particle has 2 protons and 2 neutrons, and its atomic proton number decreases by 2. When an unstable nucleus emits an alpha particle, its mass nuclear number decreases by 4. Compared to a beta particle, an alpha particle causes less ionization, has less charge, has less mass, has less penetrating power. It has less penetrating power. Describe how a teacher should measure the activity of a radioactive source using a Geiger-Müller detector. So use the counter to measure background radiation, and a safety precaution based on distance of use tongues and slash shielding, etc. Controlled variable time, distance, positioning. Example, source nearby to detector for a minute. Practical consideration, repeat, average, reset scalar. Mention of Becquerel. So 4 marks, any 4 from these 6 things. So, use of these, measuring the background radiation and subtracting it. Keep in mind the safety precautions such as shielding and using tongues. A controlled variable time, distance slash time slash distance slash positioning. Example, source nearby to detector. Source nearby to detector for a minute to get an average. Practical consideration, repeat it and get an average, and close the detector for a minute to get the whole amount to. So let it stay by the detector for a while, and so that would be better instead of just moving it for 1 second and then removing it. The distance or the time should be controlled, and repetition and getting the average, and all this mention of Becquerel. So that's how a teacher should measure the activity of a radioactive source. Which one of these is measured in Becquerel? Activity, frequency, half-life, radiation. So that's activity. Which of these has a mass nucleon number of 4? Alpha particle. Which of these is the same as an electron? A beta particle. Which of these is the most ionizing? An alpha particle. So activity, alpha, beta, and alpha. So activity, alpha, beta, and alpha. That's the answers. The table shows the nature of alpha and beta particles. Alpha is a helium nucleus. The nature is helium nucleus, as proton number is 2. The nucleus of the helium, not the helium atom, as there are no electrons, and beta is an electron. Explain why beta and alpha particles have different penetrating powers. An explanation including any 5 of these. So alpha particles have less penetrating power. That could be one. Because they have more charge, point 2, and they can cause more ionization. They are bigger, have more mass. So they have less penetrating power, and they have less range because they have more of a charge. So they're more they cause more ionization. They ionize more. And alphas are bigger, have more mass. So they're bigger and have more mass, so they travel less. And slowing force on alpha particles is larger. The slowing force is larger because of these. They have a larger charge, so they're more attracted to the particles, so they travel less further. Kinetic of energy of alpha lost quickly, causing ionization. So the kinetic energy of alpha particles is lost quickly, causing ionization. Larger alpha particles are more likely to collide with the atoms. A teacher investigates the half-life of a radioactive isotope that decays quickly. A teacher measures the background activity. Explain how this value should be used in the investigation. So in the end, the teacher should subtract background activity from each reading. Explain what is meant by the term half-life. Time for the total number of radioactive isotopes, or the nuclei atom isotopes, to a half, or for radioactivity to half. The graph shows how the activity of a sample of the radioactive isotope changes with time. Find the half-life of the isotope. So first, it is around this point, and it seems that this point is about 2400, I think. So half of that is 1200, which would be over here. Just go here. Yeah, so this one. And this is about here. So at this point is 460 minus 4, 56. So 56 plus or minus 3. So evidence of use of graph, we can draw a line and match it going down here. So from here we have it, and it's about here, and then we go there, and then we move down. So we could draw a line to show that we are using this graph. The teacher takes a new reading every 20 seconds. Suggest why the teacher measures the activity so frequently. Why does the teacher measure the activity so frequently? So idea of more accurate or a smoother curve. So the more frequent it is, the more smooth it is, or else it would be like, not smooth. Idea that activity changes quickly. That's also one. Idea that decay takes very little time. That's why she has to do it a lot more frequently. An unstable isotope of strontium has a half-life of 28.8 years. It is a beta emitter and can be represented by this symbol 9038 strontium. What is the mass number of this isotope? This is the mass number 90, meaning of half-life is half of the radioactive nuclei or atoms or isotopes to decay. Half of radioactive isotopes to half, or radioactivity to half, and mass number is 90. A person can absorb strontium atoms which stay in their bones. The strontium atoms stay in the person's bones. Explain why strontium 90 in the bones is a serious health hazard. Because beta radiation causes stated hazard, which we may state, such as causes cancer, kills cells, mutates DNA, ionizes tissue. So beta radiation causes these. And idea that strontium 90 has a long half-life. Idea that all beta emissions will be absorbed by the body. Those are the serious health concerns. When a strontium 90 nucleus emits a beta particle, it decays to form yttrium 90. Complete the equation for this decay. So, since there is an increased by 1 proton number, atomic number, it goes beta decay, so a neutron turns into a proton. The nucleons amount stay the same, but a neutron number decreases and proton number increases. So that's 90, and that is 0 and -1. The charge is -1, that's 0, and that is 90, stays 90, that's 39. Yttrium is also an unstable isotope. Explain why strontium 90 and yttrium 90 can both be described as isotopes, even though they have different numbers of protons. It's because they are isotopes. The idea of they are isotopes of different elements. Strontium 90 nucleus atom has the same number of the protons as other strontium nuclear atoms. Yttrium 90 has the same number of protons as other yttrium. Iodine 131 is a radioactive isotope that emits beta particles. The equation for this decay is iodine 131 53 atomic number turns to igcse plus 01e minus 1e. Atomic number for this iodine 131 is 53. Nucleon number for xe is the nucleon number stays the same for xe. Yes, so 53 and stays the same. This number stays the same for xe. It is 131 as written over here. Iodine 131 is used to treat thyroid cancer. This radioactive isotope is allowed to enter the tumor. Explain why iodine 131 is suitable for this treatment. Well, it is suitable because beta is moderately ionizing and it has a short range, and it also has this iodine 131 has a short half-life. Idea that iodine is absorbed easily by the thyroid, hence reduces damage to healthy cells. It is absorbed by the thyroid, so to healthy cells the damage is reduced. Does not penetrate out of the body, does not go outside of the body, therefore kills only tumor cells. Okay, that's why it is suitable for this treatment. It is moderately ionizing, short range, has a short half-life, absorbed easily by the thyroid, reduce damage to healthy cells, does not penetrate outside the body, and therefore it kills only tumor cells. There are different types of ionizing radiation. So, complete this table to show the properties of each type. Alpha particle charge is +2, beta is -1, +2, -1, and unstable nucleus. Gamma ray emitted by unstable nucleus. So the diagram shows a machine which makes aluminium foil. The machine uses a radioactive source to measure the thickness of the foil. The radioactive source emits beta particles. So this is the radioactive source, this one. It emits beta particles. Output from the detector indicates the thickness of the foil. So there's a source, there's a detector. Explain why beta particles are used rather than alpha particles or gamma rays. The reason why beta particles are used because alpha particles would not penetrate enough. Alpha particles stopped by aluminium foil a few centimeters in paper card. Idea that gamma rays would be too penetrative and alpha rays would not penetrate enough. So alpha rays would not get through enough, they would not be able to penetrate enough, and gamma rays would penetrate too much, they would not be absorbed by that and are affected, and alpha would be stopped. An idea that some beta particles will pass through the foil, not all will pass, not all of the beta particles are absorbed, and some will pass. Idea of a correlation between thickness and absorption. Thinner aluminium absorbs fewer beta. So not all would be blocked and not all would go through. Some will pass and some will be absorbed. Whereas in gamma, all would penetrate and alpha, all would be absorbed. And that's why beta particles are used. The radioactive source contains strontium-90. This nucleus emits a beta particle. Complete the equation to show how strontium-90 decays. Let's see. So this increases by 1 because neutron turns into proton, 39, and this remains 90. Yeah, so 90 and 39. So what happens is, it happens to the strontium-90 nucleus when it emits a beta particle. The number of protons stays the same, number of protons increases, number of neutrons stay the same, number of neutrons increases. So number of protons increases, B. So the number of protons increases when it emits a beta particle. Thank you.